Okay, in this example, we're going to start with an equation that's in factored form. So if we start in factored form, what do we know? Well, we know that the x-intercept is 3, and we know the other x-intercept is 1. So we have x equals 3, and x equals -1. Sorry, I said 1, but it's -1. Okay, now, if I want to know the axis of symmetry, one way I could figure it out is that it's got to be halfway between these points. But let's go ahead just to practice, and let's use -b over 2a. So if I'm going to use -b over 2a, it needs to be in standard form. So I'm going to go ahead and convert this to standard form. So I'm going to factor it. I'm going to multiply it. So I'll have something that looks like this. Then I can combine like terms. And then I'm going to actually multiply this negative sign. So I end up with y equals -x squared plus 2x plus 3. Okay, so if I'm going to do -b over 2a, so I know that the axis of symmetry is going to be equal to -b over 2a. So I have -2 over 2 times -1 is going to give me 1. So I know that my axis of symmetry is going to be x equals 1, which is, of course, right in between these two x-intercepts, and that makes sense. Now, if you remember, once I have the x, I can plug it in to get the y. So I could plug it into either form. I should get the same thing. I can plug it into the factored form if I want, or into the standard form. So I have -1 squared plus 2 times 1 plus 3. So remember, order of operations, this is 1 squared and then a negative. So I end up with 1 plus 3 or 4. Okay, so that means my vertex is 1, 4. So I put a point right here. I know that it's going to open down because I have a negative term. I have no compression or no stretch, so it's just going to be a regular shape here, like the parent function. So I can draw this, and I can draw this. Okay, so there's the general shape of it. Now, domain, I should always know, -infinity to +infinity. That doesn't change. That means I can plug in any number for x here and get out a y value. Okay, so let's skip range for one moment and go to maximum or minimum. So hopefully you can see that it has a maximum value. So when I look here, the highest value is right here at this vertex, and I can see that it's y equals 4. So the highest value is y equals 4, and I always give a max or min in terms of y. So from the max or min, I can actually get the range. So I can see that my range, the highest value possible is 4. So my range goes from -infinity up to 4. So I always put it in order from least to greatest. So the smallest number I can have for a y value is -infinity. So you can see that it just keeps going down and down and down. All the way up to the highest value is 4. So you might be used to saying something like this: y is less than or equal to 4. So this is kind of the same situation here. This bracket means equal to. Okay, so if you see a bracket, you know that that means that it could also be equal to that value. And if you see a parenthesis, it can't really equal that. So there's really no such point as -infinity. -infinity goes on and on and on. So we use a parenthesis to indicate that. All right, so intervals of increase and decrease. So think about this like a roller coaster, okay? So it's a roller coaster, and I read it from left to right. So I'm always talking about x values. So I'm looking at the x values, and as I read this graph from left to right, I can see that it's increasing, increasing, increasing like a roller coaster. So if this is a roller coaster, it would increase all the way until it gets to the axis of symmetry. So therefore, this is increasing all the way from -infinity until it reaches 1. So it increases from -infinity until the point of 1. So I'm not giving the maximum value. I know it increases up to the value of 4, but what I want to know, at what points of x does it increase? So if I look at this, let's highlight this. It increases from -infinity all the way until that point. And after that point, as of the axis of symmetry, it then starts to decrease. So if we wanted to know when it was decreasing, it's decreasing from 1 to positive infinity. So remember, we always give our increase and decrease in terms of x. Okay, lastly, our end behavior. We can say as x goes to positive infinity, what happens to y? And as x approaches negative infinity, what is happening to y? Okay, so if we look here, again, we're looking as the x values. So as I'm plugging in higher and higher and higher values for left. So I look, and again, when I'm talking about end behavior, I'm talking about the ends of the graphs. So you're looking at the arrows. So as I put in higher and higher values for x, I plug in 2, 3, 4, 10, 20, 40, 70, a million. The higher values I put in for x, what happens? Well, y gets lower and lower because no matter what values I put in here, it ends up making it negative. So therefore, as x approaches positive infinity, y approaches negative infinity. If I read it going this direction, I see as x approaches negative infinity, so the lower and lower and lower values I put in for x is actually still going to continue to get lower and lower and lower. So the end behavior, both ends, go to negative infinity.